Hi everyone. I'm Hania Ibrahim, and today's topic and tech talk will be given to you by Anwusha Naskar. The topic would be an introduction to machine learning algorithms. Now, before we begin, I'd like to point out a couple of things. Number one, if you scroll down to the event box below, you'll find the link to get a free IBM cloud account. And you should use that link when Anwusha is doing the demo, so you can get started on the demo and get all the services that you need. And second, I'll be monitoring for questions in the live chat. So if you're watching in the event page, just head on over to the YouTube page so you can ask your question and we'll get right to answering it. So Anwusha, I'll hand it over to you.
Thank you so much for that introduction. Okay, so hello everyone. And at any point, Hania, feel free to interrupt for any questions, or if there's any issues with the stream, please share them in chat and Hania will prompt. So hello everyone, and today what we'll be talking about is an introduction to machine learning algorithms. FYI, there is a previous video in this series. You can find it on our YouTube channel, and what it's called, you can search Introduction to AI and Machine Learning, and that's another previous webcast that we've run that has some introduction to machine learning itself and what it means, versus this focuses more on the algorithms. So what we'll be focusing on is we'll first go over an introduction to what machine learning is. We'll focus on different machine learning algorithms such as linear regression, and we'll look at how they work and which ones to use in what scenario, as that's a pretty common question that data scientists or developers have. Afterwards, we'll be looking at a demo of Watson Studio and AutoAI, which automates the workload of data scientists to best choose the correct machine learning algorithm. So before you get to that part of the webcast, which will be around the last half or so, please use the link in the YouTube box titled Get a Free IBM Cloud Account, and then you can follow along. So to introduce the topic, let's quickly just introduce what machine learning means and where it falls in the sphere of AI. So artificial intelligence as a whole refers to the capability of a machine to imitate human intelligence. So it's the branch of computer science related to dealing with the simulation of human behavior. This can involve things like replicating decision-making, problem-solving, perception, or even creativity. So when we use artificial intelligence, we can create things such as chatbots, recognize images, or even self-driving cars. To the right is an example of a chatbot built using IBM Watson Cloud, and you can maybe have a chatbot to, order pepperoni pizza or something. So where does machine learning fall in this? Well, machine learning is just one subset of artificial intelligence, and it refers to AI systems that are able to learn without being explicitly programmed. So the definition we'll give is evolving from the pattern of recognition and statistics. Machine learning is the field of building models to classify and make predictions from the data instead of following rules-based algorithms. So you might be wondering, what do I mean by rules-based algorithms? Or how can we differentiate machine learning from traditional statistical analysis or traditional programming? So what I mean by traditional programming is no machine learning. Maybe you're doing a typical algorithm to do something. Maybe you're doing statistical analysis. Well, what a traditional algorithm is let's say we want to make a prediction on something. We want some answers. Well, with traditional programming, we'll take data, and given a set of rules, we will create an algorithm based on these rules. Then we will use this algorithm to get answers. Answers are essentially what we're trying to predict. So an example I like to give is, let's say we're trying to predict heart failure. This could be a real problem that you're trying to predict. Maybe you have some data that's existing that has some factors related to heart failure, so just beats per minute, BMI. So with traditional programming, we take this data and we would have to input some sort of set of rules to create an algorithm based on these rules. So then we'll use this algorithm to get answers, as in the result, whether the heart will fail or not. So answers are essentially what you're trying to predict with this algorithm. You'll be trying to predict the result, whether the heart will fail. And the rules essentially will be developing a formula. It could be something like BMI minus age, or BMI times age minus 2. Like it essentially, this kind of traditional algorithm will have some sort of if then else statement. So if the data fits a certain set of rules, then a certain result will be true. So you can see the inputs, and you can see how the algorithm runs using this diagram. So this kind of algorithm, again, will not be changing, and it can be kind of confusing how we determine these rules in the first place. Like, how exactly are we determining this algorithm will work? Like, how do we use these factors to get a set of rules? Who decides that in the first place? So that's where machine learning comes in. So with machine learning, we look at data, and then we look at the corresponding answers, as in the corresponding results associated with that data. And we use this to create an algorithm that gives us the rules. So if we use the past example of heart failure, we would be looking at the data, whether the heart has failed or not, and we'd use that to create an algorithm to tell us how these factors affect heart failure itself. So essentially, machine learning is just finding those parameters in a traditional algorithm. So with this example, we would be creating a model that looks at some entries, such as the first entry. We have BPM 93, BMI 25. We'll look at the result, and it would continuously look at a lot of this data so it can develop a rule set. And then we can later use that model with that rule set to predict future answers. So in the future, we would get incomplete data that only has the factors, not the result, and would use this to predict whether it would fail or not. So this model, it's not static, unlike traditional programming. It's going to be trained continuously, and we can use this in the future to predict better future variables. So it's continuously improving. So what exactly do I mean by training continuously? Well, training essentially refers to using a learning algorithm to develop the parameters of your model. So while there's many algorithms to do this, in layman's terms, if you're training a model to tell good from bad, you'll be showing the algorithm a set of data saying this data is good, then showing the algorithm a second set of data saying this data is bad, this data is good, and you'll be repeating this process many, many times until the algorithm has modified its internal values and it's learned to tell the good from the bad. And by many, many times, it could be done thousands of times, even millions. Like, this is a long process. So this really refines the model. And then, so with machine learning, we'll take a data set and we'll split it into 3 categories: training, validation, and testing. So the subsection split for training will be the data used to train our algorithm. The validation subset is what we use to validate our results, and that's how we determine the accuracy of our model. So we have to make sure our model fits the validation data set. And So this is what we use to fine-tune the algorithm's parameters. And then lastly, how do we determine, when we finish, how do we determine that our model is accurate? So we use the testing data set to evaluate how accurate the model as a whole is. So it's a continuous process. And at this point, you might be wondering, what are the learning algorithms? And how do you know what algorithm to pick? Well, there's several different learning algorithms and styles, and in this webcast, we will go over a few and go into the math of how some of those algorithms work. As for knowing what algorithm to pick, there's many different factors, such as what kind of data you're working or how many resources you have. It's essentially the entire work of a data scientist to know what algorithm to pick. So what we'll be going over is a tool called AutoAI on Watson Studio. So this actually chooses the correct machine learning algorithm for you. So this really simplifies the process. So although we will go into a little bit about how to pick an algorithm, this will really show you how to do this easily. So going over machine learning algorithms, so there's three main styles of what kind of algorithm. So one is supervised learning, another is unsupervised learning, and there's also reinforcement learning. These are just some categories of machine learning models, machine learning algorithms. Give me 1 second. My slideshow. Okay, well, I'm having some issues with my slideshow, but I can talk about it here. So with supervised learning, it's essentially called supervised because we need to act as a guide to teach the algorithm what conclusions it should come up with. So with supervised learning, we require that the algorithm's possible outputs are already known and that the data used to train the algorithm is already labeled with correct answers. So we can look at this picture over here. Essentially, we need to know what the possible outputs are. In this example, it's white circles or black circles. And we need to know that the training data is already labeled. Like, we need to know that these are black and these are white. We can't just look at a bunch of unknowns. So different kinds of supervised learning are classification and regression. So regression models essentially look at the relationships between a bunch of features X and the result Y, and we'll go more into these algorithms later, but essentially regression is used for continuous values, versus classification focuses on discrete values. It identifies two unique classes, such as the difference between these circles and these plus signs, versus this is, over a line. So the example I gave earlier about heart failure was an example of classification, where the classes would be either heart failure or a healthy heart. So when we choose which one to use, we can think about the outputs. So if the output is a real number, we can call the task regression, such as if your outputs is going to be a number, but if the output is going to be a limited number of values, like it can be, heart failure or not heart failure, or maybe circles and plus signs, then if these values can't be, ordered numerically, then it's classification. So that's just one example. If you're using supervised learning, what kind of algorithm you would use. Unsupervised learning, on the other hand, it's focusing on inputs that we don't have labeled. So an example of this could be, with supervised learning, you'll have an input of maybe a spreadsheet with different categories saying, these are the beats per minute, these are the BMI, these are the results. With unsupervised learning, instead of having a spreadsheet, you might just have pictures. And maybe from those pictures, you can gain some insights based on, um, maybe the position of the hand. So unsupervised learning is more closely aligned with what some people might think of when you think of artificial intelligence, as in the idea that a computer can learn to identify complex processes and patterns without a human to provide guidance along the way. So there's essentially less information about objects, and since we're using unlabeled training data, we're going to be using unstructured data and determining labels. So you would essentially pick an algorithm in this category if you have unstructured data, such as pictures or maybe a video feed or something that's not labeled. So this kind of learning algorithm is typically done through clustering algorithms. So it's possible to observe some similarities between groups of objects and unstructured data and include them in clusters. So in this picture, we can see that we have a lot of unstructured data. We just have a lot of different colored smiley faces, but it's possible to kind of cluster them based on the color and like where they are in the graph. And that's kind of how it works. Another category is reinforcement learning. And what this refers to is goal-oriented algorithms. And essentially, it uses a reward function to penalize bad actions or reward good actions. So something you could use reinforcement learning for is maximizing the points won in a game over many moves. So it differs from supervised learning in the way that supervised learning, the training data is important. So that's essentially with supervised learning, the model will be trained with the correct answer itself. But with reinforcement learning, there's no answer, but the reinforcement agent is the one that's deciding whether to perform a certain action or not. It's essentially it's learning from its experience, so it's kind of like a feedback loop. So it's a different style of algorithm. You can imagine a mouse making a decision in a maze based on like whether it gets the cheese or not, and based on its observations where the cheese is. So you can kind of think of it about it like that. And it's just a different style of machine learning algorithm. So those are the three main categories, but within these categories, there's, many, many different machine learning algorithms. So I just listed a couple here that you might have heard of. Linear regression, random forest, naive Bayes classification, independent component analysis, decision trees, recurrent neural networks. Essentially, there's a lot. So we will go over a couple common ones, but because there's so many, it's honestly impossible to understand all of them, but you can have an understanding of some of the most common ones. And a lot of these algorithms you can actually implement in Watson Studio, which we will demo later. So let's go into linear regression. So linear regression is a statistical method that allows you to summarize and study relationships between two continuous quantitative variables. So you'll have, remember, we're only using this when, the output is quantitative. Essentially, you're trying to find a line of best fit that best fits your data. So you'll have X, which is your input training data. This is univariate, so only one input. And then you'll have Y, which is what you're trying to find out. So Y will be the labels to your data. So what the answers are associated with the X data. And so when you're training the model, you'll be trying to find a line of best fit to best predict the value of Y for a given model of X. So we can see right here is the regression. So that's the equation you're trying to find out. With theta 1 being the intercept, theta 2 being the coefficient of X, And the line of best fit is found when we find the best theta values. So when we finally, at the end, use our model for prediction, we'll be predicting the value of y for the input value of x. So by achieving this best fit line, the model will essentially try to predict y so that the error difference between predicted value and true value is minimum. So remember earlier when we said we'd split up the data set into training, validation, and test? So what it will do is it'll take the test data set and the true value of y for a certain variable in the test data set, and it will compare it with what the equation predicts for those input parameters, and that is what you're trying to minimize, and that's what this equation right here means. So you'll have a cost function right here. So this cost function j is, we call it the root mean squared error between the predicted y value and the true y values. So this is used in linear regression to accurately, we're basically trying to minimize this, and it's just another way of speaking about the error. So how exactly are we finding these theta 1 and theta 2 values? So something we can do is called gradient descent. So what we do is we'll start with random theta values, and you iteratively update these values until you get minimum cost. So that's what we focus on the equation j for. So with gradient descent, that's one algorithm you can use with linear regression. So when do we use linear regression? So we use it when we're told to predict some sort of future value of a process that's currently running. It's pretty simple, but it actually is pretty accurate when there's thousands of features. So for many complex algorithms actually suffer from overfit issues, and if the data set isn't huge, many complex algorithms don't work well, but with large data sets, linear regression works pretty well. However, it's kind of unstable in case features are redundant, so if you have many different features, it might not work that well. So these are just some things you can keep in mind when you're deciding what kind of algorithm to use, whether to use linear regression. But again, with Watson Studio and AutoAI, it kind of does this work for you. But it's still, sometimes you want to know what linear regression is and what that means. So another another algorithm that's very popular is k-means clustering. And this is a different kind of algorithm, and I picked this because this is a clustering algorithm, which is really different from finding a line of best fit. So you would use this for different kinds of data. You wouldn't use this if, looking at this picture, it wouldn't make sense to find a line of best fit to fit this data because there's clearly 3 distinct classes of data. The output isn't quantitative, it's maybe 3 different categories. So maybe you're separating a bunch of boxes from spheres, from triangular shaped objects. That's something you could use k-means clustering for. So how exactly does this work? So you need to know how many categories you think there will be. So in this example, we would call that k. So the amount of categories is k. So in this example, k would be 3. So the process is you would take a large group of all this data and split it into k smaller groups. So the process would involve first picking a centroid for each group. And by centroid, I just mean a point. And then for each centroid, you would just allocate all the nearest points to the nearest centroid. So if you just picked a point here, whoops, you would find all the points, that are closest to this and categorize that in this category. If you picked a point here, you would find, all the points that are closest to this point. So essentially, you would find 3 random centroids and you would separate it into 3 categories based on what's the closest to create 3 clusters. And then you would calculate the mean of all the values of each point belonging to this cluster. So once you have, this cloud, you'd find the mean of all the values, and that point would be the new value of the centroid. And this process would be repeated many different times until the centroids don't change, which means that they've been accurately grouped. So essentially, let's say you have, maybe a couple data points, and then there's some apples, some pears. Maybe there's 5 apples and 6 pears, but you don't really know this. So you would pick 2 random data points, and then for your first pass, you would just find what objects are closest to that apple or pear. And then, then you'd check for each group, like maybe there's 3 pears and 1 apple in one group, and for whatever this, you take the average of all these points to use this as a new starting point, and you'd keep doing this until, you only have apples and you only have pears in a certain group. And you do this with the test data, so you would know whether they're an apple or a pear or not, but then you'd apply this to new unstructured data, and you could use this to classify an unknown group of objects. So another machine learning algorithm is called support vector machines. So with support vector machines, what the purpose of this is to separate things into 2 distinct categories. So it's kind of similar to clustering in the sense that, we're separating things into 2 categories, but what we do is we essentially take a line to separate 2 different categories, and it can be multidimensional too. So that's what we call the lines hyperplanes. If we can't neatly create a line in 2 dimensions, we can create a 3-dimensional plane to separate 2 categories of objects. In this example, in this picture, we can see, 2 different sections of the data, and we can see a place where we can cleanly put an hyperplane to separate the 2 categories. And this can have many different dimensions as well. So what it would do is it would map points to higher dimensional spaces using kernels. And it can use, in the original space, it might look like a weird curvy line, but in a multi-dimensional environment, it would separate them into 2 classes. So when would you use support vector machines? Well, they're pretty accurate with small or clean data sets, but with large data sets, there's a really long training time, so it's not suited. So it's important to consider the size of a data set when picking a machine learning algorithm. So support vector machines traditionally have been used a lot for text classification tasks or even handwritten digit recognitions. So something that's important to consider is historical precedence. So, if over time a certain machine learning algorithm has been popular for, a certain task, that might be the best choice on what to use. So at this point, I've gone over like a few different kinds of machine learning algorithms and when you would use them. But I think now it's time to demo using AutoAI, how this process can be done for you. But again, in chat, if you have any questions about any other machine learning algorithms, Hanya can maybe link you to some resources, or I can try to explain later on. So let me switch. Okay, So at this point, what I want everyone to do is to go to the YouTube page, and in the description box, there is a link that says sign up for IBM Cloud, and you can create a free account, and this will be used to complete the demonstration. Everything in this demonstration can be done for free. So I already have one. So I'm going to log in. And if you want to follow along the code pattern, once I log in, if you go to developer.ibm.com, you can search for this particular code pattern. It's also linked in the YouTube description box below. But I'm just going to be following along this code pattern, generate a machine learning pipelines to best choose the best model for your problem. So once you log into IBM Cloud, you'll be taken to your dashboard. So give me a second. So the first part of this is to create cloud object storage. So you'll go to the navigation menu, and then go to where it says storage. So go to the navigation menu, and there should be a storage tab. Where is that? So you can just type in object storage, and my internet's being a bit slow. So you can select a light pricing plan. You can also name it, and you can also then click create. If you already have one, you'll get the error that you've already created a service instance. So if you already have one, you can just see it here. So you can go to your resource list, and you can see that under storage, I've already created one earlier. So this storage service will just be linked to your project. Another prerequisite is to go to Watson Studio. So you can just search Watson Studio. So Watson Studio is a tool that we'll be using. It's essentially a platform where we can do a lot of machine learning related tasks without much programming knowledge. So again, just create an instance of Watson Studio. And I already have one. So if you already have one, don't worry about it. But anyway. So when we get started, let's go to Watson Studio. So for the first step is to create a project. And in this project, we'll essentially train a model with AutoAI. So let's click Create Project. So we'll be creating an empty project. So you can call it test project tutorial. So we created the cloud object storage earlier, and it's linked automatically, but if you have a couple, make sure you select one. What's cool about Watson Studio is you can actually collaborate on projects together, but for this tutorial, we won't worry about that. So in this example, if you go to the code pattern, if you go down to step 5, it's going to tell you to download a CSV file called German credit data. So essentially, what are we going to be doing here? So this data is just credit data. Hang on. Let's upload it. I'll explain the data set once we upload it. So click Add to Project, and then so I already downloaded it, but if you're wondering where to find it, it's in the code pattern. And let me show you. So using Data Refinery, you can easily browse and refine your data. So we don't need to refine the data for this tutorial. I just want to go in and explain what this data is. So this is data related to credit scores. So something a bank might want to do is, minimize the risk when they give a loan. So they might look at data related to credit scores to predict whether the customer will be able to repay their loan or not. So if the applicant, has a good credit risk, then they might, if there's a lot of risk, then they might not be able to pay the loan, etc. So essentially this data set is just 1,000 loan applicants with different factors and whether, they repaid the loan or not. So that's what we're going to try to predict. But, oh, okay. Well, let me see if I can share it over in Excel. Okay. So we can see here that we have a lot of different data, 1,000 rows, information like savings account, like a lot of like age, some codes referring to their jobs, telephones. It's pretty nonsensical for a human to be looking at this and be able to determine much. So that's why we'll be using, machine learning to see if we can get any insights. So here's what we will do. So we'll go to the project and click Add to Project, AutoAI Experiment. And AutoAI is what essentially will help choose a model automatically to best fit our data. And give me a second. So we can name our mod. So what we need to do is associate the Watson machine learning service instance that we created earlier with our project. So we'll click this button to associate the Watson machine learning instance, and this is what's actually doing the machine learning. Okay. So we're just using the default configuration right now. So now we need to select what data we want to use. So we'll be using this German credit data.csv. And now we want to select which column we will predict. So what exactly do we want to predict from this data? So we can see here that there's many different things we can try to predict. But what we'll predict is, so for AutoAI, we can predict many different things, but so we'll predict the result. So because the result is, either one thing or another thing, they've either paid the loan or another thing, it says binary classification. Remember earlier we said based on what you're predicting, you can have classification or it can be a regression task. So you can go into experiment settings and you can see how we're splitting the data into training and validation. You can also, change metrics, but it already picks the most recommended metrics for you. You can also change what kind of prediction type you're doing, but because this label column is two distinct categories, the tool recommends binary classification. It wouldn't really make sense to use regression because this is not a task that's suited for regression. It's two distinct classes. So let's save and close. And let's prepare the data. So basically what AutoAI right now is doing is it follows this sequence to, build this pipeline. So first it will pre-process the data, and that's what, helps select what kind of prediction type we're using. Then after that, what the first pipeline is it's automatic model selection. So it's going to be picking the best machine learning model that best fits your data. After that is hyperparameter optimization. So you can see this. And after that will be automated feature engineering. And lastly, hyperparameter optimization again. So this might take a while, but at this point, I want to open it up for any questions people have. So are there any questions, Hanya? Or hello? Hanya, do we have any questions or?
Yeah, guys, if you have any questions right now, just write them in the live chat and we'll be able to answer them. Yeah, so what is the
Hello?
So what is basically the pipeline? Like what are its components? Do you know that?
Oh, okay. So the pipelines, hang on. So the pipelines are just doing different things. So, one pipeline is doing, what it's doing is it's selecting which estimator to use. Another pipeline is then, picking parameters. It's essentially doing all the steps in what you do with data science and machine learning in a faster way. Now, let me see if I can find some more resources about pipelines. I'm trying to see if I can find an exact description of what exactly each pipeline is doing specifically. So, for example, we just saw that the pipeline that was picking the estimator said that the best kind of classifier is XGB classifier. And I'm trying to, so Hanya, if possible, like if you can find anything that links specifically to what each pipeline is doing, that would help in chat. But I'll try to look for it on the side as well.
Okay, will do.
Or was the question just what pipelines are in general? It's just, elements connected in a series. We're just separating the steps and we're executing these parallelly using IBM Cloud. So that really speeds up the process and you don't need to worry about, having the resources because earlier we selected how many CPUs we want to allocate to this, how much space you want to do. So all of this is happening in the cloud. That's what these pipelines are running on. So earlier when I talked about different machine learning algorithms, some of them take a lot of time, and as you can see, like we're able to do this pretty quickly because it's running across multiple cores on the cloud.
Yeah. Okay.
Any other
questions? Got it now.
Just waiting for this to finish.
Yeah, I found a link, you guys. Something that can further explain the different type of pipeline. So you can check it out. I just posted it in the live chat.
Thank you so much, Hanya. I didn't have this information like memorized, so thank you so much.
Yeah, you're welcome.
Oh, okay. So that's pretty cool how we can see this. So we can see what's happening with this pipeline. So we can see, feature engineering, that it selected these things, and so as this is running, it's not completed running.
Yeah.
But we can see over here. Oh wait, what?
And Marsha, someone was asking if there's integration with other platforms like TensorFlow and GCP.
Yes, there is. I don't know about GCP integration, but there is TensorFlow integration. Let me see if I can find a link for you. Let me try to find one. Hanya, I'm just gonna Slack it to you about like TensorFlow. You can Slack put this in the chat.
Okay.
And let me share my screen. So if you go here, you can look at all the supported machine learning frameworks. You can, have Jupyter notebooks here. There's a lot of different supported platforms that this connects to. You can connect to Cafe. So there's a lot of integration. And I'm sure there probably is a way to somehow connect to Google Cloud Platform. I just don't know off the top of my head.
Okay. I just posted it in the live chat.
Okay, it was just okay, so this has finished and it only took 8 minutes, so that's actually pretty fast. But here, what we can do is, if you go bottom, we can see all the pipelines and we can see, the area under the curve. And what this tells us is how accurate the model was, so we can select which one gave us the best area under the curve, but for whatever reason, we can, pick a different one. But so you can save this as a model, and we can like go into this model. So when you click save, you can enter a name, a description. Now let's click view in project to see what we did. So we can see let's go back. I want to show you the actual pipelines. Okay, this is what I wanted to show you. So for each pipeline 3 was, I think, so you can see the accuracy, you can see the line of best fit. The area under the ROC curve, but if it was linear regression, you would be able to see the line of best fit here. You can see the info about the actual feature transformations. So I don't actually know what XGB classifier is, but as I said earlier, there's hundreds of machine learning algorithms. So, this really helps you find some of the lesser known ones to really pick the correct classifier. You can find information about which features were the most important. So when we're looking at that data, there were so many different columns, so we can see that maybe the check account and credit history column are the most important here. So let's actually deploy this model, and I think that's, using this deployment, you can connect it to other cloud platforms as well. So go back to the project. So we'll go to deployment and click where is my deployment? Here it is. So we'll go to deployment. And
hey, Anusha, someone was asking if they can manually define pipelines.
Manually define platforms. You can using Watson Studio, but using AutoAI, so it selects, so let me show that, I think. If I can show that. So using Watson Studio, you don't have to use AutoAI to select the classification. You can do all of this in Watson Studio and then select which kind of model you want to be using. So this example is using AutoAI, but I think I have some past projects that I can demo that. So you can use Jupyter notebooks, and you can select what kind of model you want to be picking. So I think this is, I'm not sure if I can find an example right now just from based on what I've had. You can do this all with Jupyter notebooks. You can manually select pipelines. So right here, in the Jupyter notebook, we have something, we're manually adjusting the pipeline. So that's what this code is doing. So we're transforming the pipeline. So the answer is yes. Sorry I didn't have the best example to show you right now. But going back to deployments, so we can just enter in deployment name. Oops. So what this deployment means is we're essentially taking this model, we're packaging it, and we're fronting it with a web API, and we're deploying this as a new service. So we need to do this to access our model and test it out. And so the deployed model will be fronted by a public API, and the deployment code is automatically generated for you to show you how to invoke the model. So now that this deployment is complete, so we even have automatic code snippets and how to insert it into something, but you can also test it here. So you can enter some data, and this is just nonsense data I'm entering right now, so it won't really make much sense, but you know, you can test it by giving some input data. We can get a prediction. So also what you can do is you can call this model from a notebook, like a Jupyter notebook. So what you do is when you go back to your project, you can add to project, you can add a Jupyter notebook, and then from this, you can import your model. So that's something you can do. Essentially, Watson Studio is really powerful in how it can, you know, you can instantly pick which machine learning algorithm you want to be using, and we can do it pretty fast. So let me try to see if I can find some resources I can link in chat. So okay, Hania, I'm linking you. Hania, I'm linking you right now for chat, like how to actually edit the pipelines and edit the streams flow. So that's a better resource on how to be doing that. So I'm not sure if that's what they were asking, but yeah.
Yeah, okay. Just posted it right now in the live chat.
Yeah, if there's any other questions, or if you want to know about any other machine learning algorithms, I could explain them, or if anything else. But yeah, please check out the demo. It's pretty fast. You can try it with your own data set, not just you know, this German credit data, because that's not maybe something you're interested in. You could try it with any data you have and insert a column with features.
So do you guys have any other questions?
But yeah, Watson Studio, you know, overall is just a really great tool you can use that, you know, kind of takes the gap away from data scientists and domain experts. You don't need to have a huge data science background to be able to pick which, you know, data science tool to use. But at the same time, if you do have a data science background, you can easily use this to compute on the cloud your machine learning experiments as you know, it's on the cloud. We have dedicated resources to it. It's very convenient as we can easily clean and prep our data with data refinery. The visuals are really nice, seeing different pipelines and seeing how different estimators, uh, you know, work with the data. Yeah, like any other questions? And if not, um, that's all for the webcast, and please post anything else you're interested in. So Hanya, I guess if there's no other questions, we'll be ending the webcast now. So if you want to say a closing statement.
Yeah, okay. So thank you guys for joining us in today's webcast. And we hope to see you in the other webcast. We'll be having a webcast on the 25th of September. It will be about blockchain and IoT, and how both these technologies can work together to solve problems that you may face, which is basically learning how to store IoT device data on a blockchain. Be given by Oliver Rodriguez and Derek TA. So if you guys want to join us, it'll be on the 25th of September, same time as this one, which is 9 a.m. Eastern. So thank you guys for joining us.
Okay, thank you.